Okay, greater equal to 0 or greater than 0? Greater than 0. So greater than 0 is easier because it probably not gonna have a boundary issue, because when they equal to 0, that is still count as qualification. So first thing first, you factor this to figure out where the endpoint is. And that's going to be 2 cosine of x, and there's a 1 and 1. There's a 2 cosine of x. It's cosine of x. This one's negative, so it'll be 2 cosine of x minus 1 times cosine of x plus 1 is greater than 0. So this is it. This is actually a polynomial inequality, so that way you have to do a number line test. What is the number line test? You're looking for, so look for positive region. And we're going to talk about in the graph in a second. We're going to talk about decimals in a second, because on AP exam they could give you decimals. So then 2 cosine of x minus 1 equal to 0, cosine of x equal to 1/2. That only happened where? Pi over 3, and what else? 5 pi over 3. Okay, so is that what you guys get? Okay, so cosine of x equal to -1, and the x equal to pi, I believe. Yeah. So then your number line test is based on those few values. I'm going to start with a 0, pi over 3, and a pi, and a 5 pi over 3. And then I'm going to plug in pi over 6 in terms of 2 cosine of x minus 1 and a cosine of x plus 1. Isaac, you want to teach? That sounds good. I don't mind. So I will plug in pi over 6 here. If I plug in pi over 6, I will get square root 3 over 2. Square root 3 over 2 and cancel the 2 minus 1. Square root 3 is bigger than 1 because square root 3 is 1.7. So that's positive. Is that okay? Now, if I plug in, that says pi over, I'm just going to plug in pi over 6. That's going to be positive. So it's a positive, positive. So it's a positive region. Is that okay? Okay, let's plug in pi over 2. Pi over 2 is easy because pi over 2 is going to give you a 0 for cosine. So it's going to be a negative positive, right? Am I going too fast? Because I plug in pi over 2, cosine of pi over 2 is 0. And that's going to give you easy sign determination. 3 pi over 2 is also a good one to plug in. So if I plug in 3 pi over 2, I'm going to get what? Also 0, right? So it's negative and positive and negative. 11 pi over 6. 11 pi over 6 is going to get the same result as that. The first part is a positive, and that's positive. So now here's a question. Do I including 0? If I plug in 0 in here, what am I going to get? 2 plus 1 minus 1. Is that greater than 0? Because cosine of 0 is 1. Do you guys know that? So that'll be 2 plus 1 minus 1. 2 plus 1 minus 1 is 2, so it's positive. So 0 is included. Is that okay? Is this okay? Okay, pi over 3. Is pi over 3 included? We don't know. If I plug in pi over 3 here, that's going to give me 0. Because that's 1/2. So that's going to give me 0. But 0 is not greater than 0. So it's not included. So pi over 3 is not included. I will plug in either to here or here, because if I plug in here, it's going to give you 1/2 times 2. That's 1. 1 minus 1 is equal to 0. Okay.
Wait, you said pi over 3 is not included. Wait, just put it.
Yeah, I plug in pi over 3 here, right?
So you plug in like the optional value?
Yeah, I plug in here, but if one of them is equal to 0, then you times other thing is going to give you 0 as well. But 0 is not less than 0. So it's not true. Now I'm going to plug in 5 pi over 3. 5 pi over 3 is going to give you the same result, so it's not going to include it. And 2 pi is going to give you the same result as before, so it's bracket. So we're looking for greater than 0, right? Why do I need to do pi? Because they are negative. It's negative to negative. That, at most that's 0, but it's not gonna. 0 is still not greater than 0. Okay, let's look at this graph though. Guys, on AP exam, you get to have graphing calculated on some part of the question. So how do you analyze this graph? Let's say 2 cosine. So this is how you check your graph on the AP on the thing on the exam. Square of x, what is it? Minus cosine of x or plus cosine of x? Okay, plus, fine. Let's do plus. And then what? Minus 1. Do I graph equal to or less to? No, I just look for this region. So I'm looking greater than 0. I have to do 0 to pi over 3. They are above x-axis. That's greater than 0. Does that make sense? It's above x-axis is greater than 0. Does everybody understand this part? Because sometimes you just have to plug in a graphing calculator and just analyze it. Why should you bother to solve? Not necessary. In this part, pi, Winston says, do I need to test someone? Well, pi is going to give you a 0. 0 is not less than 0. So it's actually 5 pi over 3 to all the way to the 2 pi. So 5 pi over 3 not included all the way to 2 pi. And that's how you set the equation like that. Questions? Now, sine of 2x, what's the next one? Sine of 2x? Sine of 2x is what? Less equal to? What? Sine of x? Okay, so first of all, sine of 2x minus sine of x, that's in 0. You should recognize that. You should also recognize that this is 2 sine of x, cosine of x, minus sine of x, less than 0. How many of you guys recognize that? Good. So that's double angle identity. Then you can factor this now. And then you can factor and you can say, well, sine of x equal to 0 at 0, pi, and 2 pi. 2 cosine of x, I feel like we just did what, 1? And that's at pi over 3. And what? So then we're going to do all those intervals. So sine of x and 2 cosine of x minus 1. And this is always positive, positive, negative, negative, because sine of x is above x-axis is positive, below x-axis is negative. Is that okay? Okay, let's just say before pi over 3. Before pi over 3 is pi over 6. Pi over 6, it could be, that's going to be positive, I believe. Everything here is negative, negative, positive. So this is negative, positive, negative, positive. Now, greater than equal to 0. What happened if I plug in 0? That's going to be 0 less equal to 0, so it's going to be including 0. Wait, hold on a second. We're not including 0. We're going to go with less than 0, so that means I'm looking for negative region. Pi over 3 to pi. Is pi included? Probably. Pi over 3, is that included? I don't know. Plug in pi over 3. That's going to be 0, so that's included. Because 0 is less equal to 0. Also pi, comma 5 pi over 3. And then this is all included. Yeah.
Find out if it's included. Do we just plug it in?
What?
Like you're finding out if it's included, right? But if it's brackets or parentheses.
Yeah. So imagine that if we have that we don't know that pi over 3 is. We're gonna plug in pi over 3 here. That's 2 times 1 half minus 1. That's 1 minus 1. That's 0. So this part equals 0. But anything multiplied by 0 is 0. And 0 is also less equal to 0. Yes. Because the result of this one's 0.
Sine x.
No, if I plug in pi over 3 into there. What is sine of pi over 3? Well, what's cosine of pi over 3? 1 half, right? 1 half times 2 is 2. Cancel out. 1 minus 1 is 0. So 0 times anything, it doesn't matter what kind of the things here, it's still going to be 0. Because 0 times sine of x is still 0. So 0 is less equal to 0. Now, if you don't believe me, you can type in the chat. You can type in the thing. So to say, hey, let's figure out sine of 2x and then what? Minus sine of x. And we're looking for negative region, which is from here to here. Pi over 3 to pi. Pi over 3 to pi included because at those 2 points are equal to 0. And also 5 pi over 3 to 2 pi and included. On AP exam, you're allowed to use decimal on half the questions. Yeah, my test, no. On my test, I'm gonna on my homework I can check the answer. On my test, you're not gonna be able to do it because I'm preparing it without calculator. Yes.
When you go back to it, why did you put pi to 5 pi? Very good.
Not right now after school. Yeah, please. Yeah. So, can you repeat that again?
I said, why did you like when you go back to the question? Why did you put like as an interval pi to 5 pi? That's a positive region. You're looking for negative.
Oh, I'm looking for negative region. I'm sorry. I'm looking for less than 0. Oh, so less than 0. Yes, I'm looking at for this one. I'm so sorry. So this one's crossed out, and I'm gonna say, wait, I'm looking for negative region. Oh, so it's pi over 3 to pi. Is that right?
Yeah.
And then so 5 pi over 3 to 2 pi, right?
Yeah.
Okay, sorry. That was just misunderstanding. Huh?
So you plug in like the next to like the sign of it.
I think plug-in a factor form is easier because factor form is a true representation of the form. But sometimes you say, let's just say factor form, you have something that's called 0. 0 times anything is equal to 0. So for example, I can plug in pi over 3 into here, right, into here. That is going to give you 2 times 1 half. That's 1 minus 1, 0. And 0 times any sine of pi over 3 is still going to give you 0. But 0 is less equal to 0, which is true, so that's holding the endpoints. I only need to put it here because my result is 0. Now, since 0 times sine of x is still 0, that result is still going to be final 0. But you can plug in if you want. Doesn't matter. Sine of pi over 3 is going to be square root 3 over 2. Square root 3 times 0 is still going to be 0 because those two factors multiply each other at the end. And that's why you get your sign or you get your value. All right. Proving identity. This is going to be used to be one of the hardest sections. But I think since we deal with a lot of trigonometry identity already, this one here, it will seem a little bit easier for you guys. So what I mean by proving identity, how much time I have? 10 minutes, right? That's a lot of time. So verify identity. So what I mean by verify identity is proving identity is true. This one we're not solving. So don't get confused between solving versus proving. Proving just prove left side is equal to right side. So proving or verifying proving or verify. So solving, you're gonna solve for some type of x. Some type of x. Proving is just prove the right hand side is equal to right hand side. Like prove this two triangles equal to each other. Right? This ABC equal to C DF from yesterday is your thing, and there's a question over there with a Stokatoa question over there on your SAT yesterday. Yeah. So you're saying this triangle is equal to this triangle. That's it. So what happened is it usually has two sides. SEC of x, COT of x equal to cosecant of x. So on here, we're going to name it right-hand side. Oh, sorry. I don't know more right. It's left-hand side. And this is right-hand side. You just try to prove a more complex side is equal to the other side. That's it. Is this a true statement? Look at it. Is this true statement? How do you know it's true?
It's true. Then you do 1 over cosine times cosine of sine.
Sydney, you're a genius. I didn't even teach you. You already know how to do it. So, hey, if I convert everything to sine and cosine, this is a 1 over cosine. This is cosine of x over sine of x. And this cancel out. Now, what you're going to do is you're still going to say cosecant of x, and then say 1 over sine of x equal to CSC of x. You don't change. Now, you're going to say, oh, yeah, that's just going to be cosecant of x because that is true. And you just did it first. Used to be, this section used to be hard, but I don't think it will be hard. So that's the easiest one. So usually, the rule is if you have secant and cosecant, convert to sine and cosine. Something probably bound to cancel. You just only have to do something to the left-hand side. Right-hand side, keep the same. The simplified side, don't change it. Don't pivot. If you pivot, it's going to confuse yourself. Only focus on the more complex side and just work out the most complex side. Try to make that side look like the right side. Got it? Okay, I should try one here. I mean, this one's a little bit harder. Now, this one's probably have to help you, but I'm going to start with this. Sine of x, tan of x plus cosine of x equal to secant of x. Sine of x, tan of x plus cosine of x equal to secant of x. Now, which side is more complex? The left side. So right side, don't pivot, don't change it, don't bother, don't just leave it like that. We just have to prove the left side equal to the right side. And you say, okay, well, I know I already have sine of x, cosine of x. I don't want to change those. But however, I can change tangent of x, right? So can I just change tangent of x? Tangent of x, what can I change to? So I'm gonna say that is sine of x over cosine of x. Is that okay? And that's gonna be sine square of x over cosine of x plus cosine of x. Now, can these two things add together? can sine square of x and cosine of x adding cosine of x? Can those two things come together? No, not right now. But can you do something for them to, they can combine? If you have, says, 1/2 plus 3, how do you add 1/2 plus 3? Common denominator. I multiply this 2 over 2, right? So this is 1/2 plus 6 over 2. That's equal to 7 over 2. Now I have a common denominator. I can add a numerator. What's the common denominator here? Cosine of x over cosine of x. Now that's going to be cosine of x on the bottom, and that's the sine square of x plus cosine square of x. And this part still didn't change. What do you see here? No, not secant. What? Nope, you cannot cancel. You kill a kitten. No, but there's other identity you can think of. Pythagorean identity. So what the Pythagorean identity says? Sine square plus cosine square is equal to what? 1 over cosine of x. So that's the secant of x equal to secant of x. And never change the right side. I can use identity to prove that this is true. So cosine of x, cotan of x, I'll let you try one. Sine of x equal to cosecant of x. Really similar. There's identity coming back to help you. So besides convert, so first trick that you can use is convert to sine and cosine. Second trick you can use is use identity. Huh? Good. It's verified. So I don't need to go over it, right? You got us? I'm gonna go to the next one. Can you guys see this? Cosine to the third x. You're like, wait. How do I say cosine? I already have everything in terms of cosine and sine. I cannot change to other than cosine and sine. No, you do not want to do something to the both sides. No. But you can do something much simpler than both sides. Yes. What can I factor here?
Thank you all again for your cooperation today throughout. Secure. It does look like we do have weather in the area. We are going to wait for the bell, but in the meantime, the flag.
Yes, I get to teach more. I'm kidding. Yeah. Darn. All right, so what do you know about this? Once you factor out cosine, what do you know about this? Again, it's a Pythagorean identity. Have you seen the book Brown Bear, Brown Bear? What do you see when you grow up? And I call this a brown bear. I see it. I see the brown bear because if I move the sine square to the other side, that's equal to cosine square of x. And that's a cosine of cube of x. What?